Hi, and welcome to this new video in the series on Bluetooth Low Energy technology. My name is Mohammed Afani, and in today's video we'll be talking about power consumption and battery life in BLE. Some of the topics we'll address in this video include power consumption expectations, the BLE parameters that affect power consumption the most, and how to optimize your BLE application to maximize battery life. So what is power consumption? Power is the energy consumed by a device per unit of time. It is measured in watts or kilowatts depending on the application in use. Now, measuring the average current is probably the simplest way to get a good idea of how much power is consumed by your device. At a high level, power consumption is mainly decreased in microcontroller applications and embedded systems in general by reducing the radio communication and increasing the sleep cycles as much as possible. Some of the more specific ways to reduce power consumption include choosing the right hardware, reducing the radio on time, sleeping as much as possible, and lowering the transmit power of the radio. In theory, reducing power consumption sounds simple and straightforward. However, when trying to accomplish this in practice, it can be much more complicated. For example, different variables such as the change in temperature, the humidity, obstacles, radio interference, and others make the task exponentially more difficult. In terms of power consumption expectations, there is no one simple formula to follow to calculate it, but rather it depends on multiple factors. Some of these factors include the chipset and the BLE radio that's being used, the BLE stack and the version of Bluetooth that's used, the tuning of the BLE parameters of your application, as well as the efficiency of the firmware and the code running on your device. Now in this video, we will focus more on the BLE parameters and how each of them affects the power consumption of your device. To follow up on that, different types of devices, depending on the application, can consume varying amounts of power. For example, devices that operate in advertise-only mode, such as beacons, can run on a coin cell battery for months or even years, especially if they don't advertise that often. Whereas devices that establish a connection and engage multiple peripherals will consume a lot more power and may need larger batteries in order to run for extended periods of time. One example would be an electronic lock that operates over BLE but also engages a motor and other peripherals attached to it. A good way to better understand what parameters impact power consumption and how to optimize it is to look at the cycle of a BLE device. In this case, we are looking at it from the slave device's perspective. Here's a graph showing the current consumption level on the y-axis and time in the x-axis. The device stays in sleep mode most of the time, and occasionally it'll wake up at the connection interval in order to send and receive data from the master. The wake up of the chip and radio causes a spike in current draw, so that's something to keep in mind, as some batteries have specific tolerance for these current spikes. After that, there may be some pre-processing before it puts the radio in the receive mode, at which it consumes more power. After receiving the data, it goes into transmit mode to send data back to the master, and depending on how much data there is to send, this may last a while, which could greatly affect power consumption. The next phase is to process the data that it received from the master, after which it goes back into sleep mode. Now, based on this cycle, we can notice a few variables that can have a great impact on battery life. At a high level, we could get the most optimization by not waking up as often as possible. Now, this could be achieved by adjusting the connection interval and the slave latency, which we'll talk about in a little bit. The next one is how much data we are receiving from and sending to the master. If you have control over the master device, then optimizing the amount of data being transferred can help a lot in reducing power consumption. The same goes for transmission from the slave device. Now, another variable is the amount of processing done after the receive and transmit cycle. If the processing can be optimized to be faster, then that would help decrease power consumption as well. The processing can also be correlated with how much data gets received from the master. The last one is the use of notifications and writes without responses when possible, which will remove any need for acknowledgement and confirmation packets back and forth between the two devices. To summarize, here are the BLE parameters that affect power consumption the most. First, transmit power. then the advertising interval, the connection interval, slave latency, size of characteristics, and the operation types. Let's go into each of these in a little bit more detail. Transmit power is one of the main factors affecting power consumption, especially when the radio is used a lot. The lower the transmit power, the lower the power consumption of the radio, and the longer the battery life. However, keep in mind that the range is greatly affected by the transmit power value. Outside of connections, in advertising mode, one of the main parameters affecting battery consumption is the advertising interval. Knowing that though, it's recommended to find the optimized value that strikes a balance between how long it takes to discover the peripheral and the power consumption of the device. This is even more important when dealing with devices that stay in broadcast or advertising mode, such as beacons. Another parameter that affects the current consumption during advertising is how many payload bytes are sent in each of the advertising packets. Therefore, it may be beneficial to place the most important advertising data in the primary advertising packet and place all the secondary, not so important data in the scan response packet, which only gets requested when necessary. In the connected state, there are multiple parameters that can be optimized to increase battery life. First, the connection interval. The longer the connection interval, the longer the devices can stay in sleep mode, causing a decrease in power consumption. Another parameter is the slave latency. Now, we've talked about slave latency in a previous video, and it defines how many times a slave can safely skip the connection event. This also leads to longer sleep periods and less frequent wake-ups of the radio, which can cause a decrease in power consumption. Now, keep in mind that this value only defines the maximum number of connection events that the slave can skip, so the slave can still wake up at each of the connection events to send and receive data from the master if that's necessary. The bigger the size of the characteristic being read or written, the longer the radio stays on, causing an increase in current draw. So keep in mind that having a characteristic that is optimized in size can help in reducing power consumption. Another aspect that helps reduce power consumption is choosing an operation type that doesn't require a response from the other side. For example, choosing write without response or notifications instead of indications can help reduce power consumption because it does not require the other side to send back a confirmation or an acknowledgement packet. Connected devices still need to advertise before getting connected to other devices, so the advertising interval is still relevant and needs to be optimized. However, keep in mind that optimizing the advertising interval will have a limited impact on battery life beyond a certain point. For example, the current consumption will be lower during the advertising state. However, the central will take longer in order to discover the device that's advertising, which can cause longer advertising periods. This may lead to a higher power consumption when compared to the case with a lower advertising interval. In the next video, we'll talk about security in BLE. We'll talk about how secure BLE is, we'll cover some of the misconceptions and myths around security in BLE, and we'll talk about how to optimize your application to be more secure. To learn more about Ellisys, provider of the world's most advanced Bluetooth analyzers, visit ellisys.com. Have a need for training or consulting services? Then contact our training partner, NovelBits, at novelbits.io. I hope you've enjoyed watching this video and learned a little bit more about BLE. Thank you for watching, and I'll see you in the next one.